So today we're going to discuss factoring, all right? Let's just think about the number 6. Number 6 is a composite number, right? We can factor number 6. How can we factor number 6? What would be? If I just ask you to factor the number 6 into prime numbers, the product of two prime numbers, what those numbers would be? 2 and 3, right. 2 times 3. So the product of 2 times 3 is 6, and factoring means you go back to that, okay? So, so let's start. We already studied product of polynomials, right? So let's just look at this situation here. If I have x plus 2 and then x plus 3, okay? So we have x here and x here. I have number 2 and number 3, okay? To do that product, we use the FOIL method, right? So x times x is going to be x squared. X times 3 is going to be 3x. Then 2 times x is going to be 2x. And then 2 times 3, right? 2 times 3. I'm going to leave this product like that on purpose. Now, we can combine the like terms here, all right? Applying the distributive property, I can, take the x out of it. So, and then I'm going to have x squared 3 plus 2, x plus 2 times 3. All right? So now let's calculate that. It's going to be x squared plus 5x plus 6. All right? So what is that we notice here? What do you see here? What's happening? If I look at the 2 and 3, what's happening here? This is the coefficient of the variable x, right? What do I do there?
You're adding it.
I'm adding it. Very good. So here is the sum. And here, what is happening here?
Multiplying.
Yeah, it's the product, right? The product, right? Multiplying, right? So, so if I have a different number here, 5 and 3, can you guess what's going to be the end product? If I have, let's say I have x plus 5 and then x plus 3. Can you go straight to the answer? Can you tell me what was going to be the answer? It's going to be what? What is the first term?
X squared.
X squared. What is the second term?
8x.
8x. And what is the last one?
15.
Perfect. So, when I have this situation, this is going to be the sum and this is going to be the product, right? So now, if I come to you and say, I have x squared plus 10x plus 16, and I ask you, can you factor that? Can you come up with two numbers that the sum is 10 and the product is 12? What are those two numbers? Okay, 8 and 2, good. 8 and 2, excellent. Yeah, let's test, okay? Every time we guess something, right, we need to test, right? This is called guessing and testing, right? So the guess is that 2 and 8, the sum is going to be 10, that's good. And the product is 16, perfect, okay? Now, sometimes it's difficult to figure out that, right? But one way to come up with that is always look here at the product. How many different ways I can multiply two numbers and get 16? Well, we can start with 1. 1 times 16 is 16. Then the next one is going to be 2. 2 times 8 is going to be 16. And then we have 4. 4 times 4 is also 16. Okay? Those are all possibilities. And remember, I could have also all the same numbers, but with negatives, right? Because negative times negative is positive 16. So we actually have 6 different possibilities that is going to give me the product, 16, right? But then we need to test the second one. The second condition is that the sum has to be 10. This is the only one that is going to give that this condition, right? Is that okay? So you guys already learned how to factor now, right? Another example would be x squared plus 8x plus 15. Anybody else can try to figure out what is this one?
X plus 5 and x plus 3.
Exactly. X plus 5 and then x plus 3. Excellent. Now, why are we doing this? Why do you think we're doing this? This is a quadratic polynomial, right? It's a quadratic. If I put here an equal sign and 0, this becomes a quadratic equation, right? And equations, what is about equation? What are we looking for in equation? If I write 2x equals 6, and I say solve this, what is that I'm asking you to do?
Solve for x.
Find the value of x. Excellent. Find the value of x, right? Well, here I have another equation, and I'm asking you basically find the value of x, right? Find the value of x. But the problem is quadratic equation has this degree here. It's 2, right? It's more difficult. It's not like this one here. Here we can just divide by 2 on both sides and get the value of x. This is more complicated, right? However, if I'm able to factor, what happens when I factor? When I'm factoring, what is happening to the degree of this here? What happened? Has reduced from 2 to 1. And this, you have to remember that this is a product. A product of 2 numbers is equal to 0 when one of them, right, is 0. Right? At least one of them needs to be 0, right? Isn't that true? It's a property. You know, a product of A times B is equal to 0 only if A is equal to 0 or B is equal to 0. Okay? A equal to 0 or B equal to 0. So it's going to happen the same here. So what is the value of x that is going to make this here be 0? Well, x plus 5 equal to 0. X is equal to negative 5. That's one answer. Or x equals negative 3. The second answer. Okay? Is this good? But what does this really mean? What does values here really mean? Okay? When I write something like this, let's say I have y equals 2x plus 3. Okay? Y equals 2x. This is the linear equation, right? The equation has 2 variables. I can graph that. If I graph that, it's going to look something like this. And here is the y-intercept, and 2 is the slope. We know all of that. When I make y equal to 0, it's going to be 2x plus 3. What is the value of x? What is the value of x?
Minus 3 divided by 2.
Yeah, but what does that mean in terms of the graph?
It's the slope.
Is the slope? X equal negative 3 over 2 is the slope?
Oh, it's the x-intercept?
The x-intercept. Exactly. This is the x-intercept. This is negative 3 over 2. Excellent. The x-intercept. So what do you think when I could have y here, right? I could have y here. But when I make this y equal to 0, What is that I'm really finding? What are those two numbers? They are the
X-intercept.
x-intercept, right, of the quadratic equation. And the quadratic equation is a straight line? Yes or no?
No.
No. Quadratic equation looks like what?
Parabola.
A parabola. So a parabola is something like this, right? It's not a straight line. So if I have my x-axis here, what's happening? How many intercepts I have? 2, right? Isn't that true? I have 2 intercepts there, right? Now, if I keep moving this thing up, I still have 2 here, right? I still have 2. But if I keep moving it up again, at some point, I'm going to have only 1 point here. So, a quadratic equation can have at most 2 solutions, right? Or 1, right? We can have 1, right? When is that situation that we have 1? What do you think? What is that situation? In what condition do we have only 1 here? What happened to these 2 numbers?
They're the same.
They are the same. They are the same. So let's do here x plus 2. X plus 2. So here, I already know that where's going to be my intercept? Can anybody tell me where's going to be my intercept? If I graph here, where is the intercept? Negative 2. Exactly, negative 2. So it's going to be something like that and something like that. Okay? There is another parameter interesting here, is this one here, right? We don't know that yet. But let's do this product here to find the quadratic equation, right? So if I do this y here, so this is going to be x squared plus 2x plus 2x plus 4. So now I have y equals x squared plus 4x plus 4. Okay? You see, the sum is 4, the product is 4. All right? And when I make this y equal to 0, right? Y equal to 0, right, is right here. I have my y-intercept, only 1 intercept, right? Only 1. What about this value here? Can anybody tell me how to figure out this value? I want to know what is this value here. How can I figure out? This is my quadratic equation. How do I figure out exactly this value? This is, what is this point called?
Y-intercept.
The y-intercept. How do I figure out the y-intercept?
You plug in 0.
X equal to 0. Excellent. If I set x equal to 0 here, this term goes away, and what is left? 4. So this point is 4. Okay? Is that good? So this is, we covered factoring, and we covered quadratic equations, how to solve quadratic equations. This is one of the methods to solve quadratic equations. Now, there is another situation when we try to solve quadratic equations that the parabola does not intercept the x-axis. Like, it had moved up so much that lost the intercept, the x-intercept. So that situation we're going to see later is related with complex numbers. We're going to have a non-real solution, all right? But that we're not covering that yet. It's just for you to have an idea of what's happening. So another application of factoring is when we want to simplify rational expression, right? For instance, if I have 2 over 6, and I say, is this the simplest form? No, this is not the simplest form, right? How do you simplify those? We factor 6. Basically, we factor 6. So we have 2, and 6 is 2 times 3. So 2 divided by 2 is 1, so it's going to be 1 over 3. Okay? So this is a numeric example. But I could have an expression like this one here, okay? I could have this guy, let me erase this here, so I could have x squared plus 8x plus 15 divided by x squared plus 5x plus 6. And I say, can you simplify this? Well, at first, when you look at it, this looks very complicated. Say, oh my God, you know, can I simplify that? You know, right? But if I remember this strategy here of factoring, right? So, can I factor that? Oh, sure, I know how to do that. Eugene taught me how to do it, okay? So I'm going to have x plus 5, x plus 3, right? And here I can use the same thing, you know. It's going to be what? X plus 2, x plus 3. Oh, 3 and 3, that's the same. Bingo. That's it, okay? So we covered 3 topics right now, right? First, I talk about multiplying binomials, right? Then I talk about factoring. Then I talk about solving quadratic equations using factoring. And now I'm talking about rational expressions, okay? Is this good? So we're going to stop here now, and you guys can continue working with, you know, Moodle on the links that you have there for factoring, rational expressions, and quadratic equation. All those 3 topics, okay, we have covered. Thank you.